some see also links. It'll be helpful if you download the Excel workbook, this first one, and the third one, tutorial guide, if you want to follow along.
I'm just going to lean back here.
Just lean back there, Timothy, that's fine.
That's my contributions. I'm sorry, just to be clear, if I was running a PC
Yes.
and I had Office 365 that's installed on my local machine,
Yes.
this would work.
This would work, yeah. Because that's still, like, Office 365 is the branding, which just means it's the subscription.
Yes.
Yeah. But you're still, it's a local install of, it's the local desktop install version of Excel. There is Office 365 you can also like run in a web browser, which makes it slower because anyways, and that doesn't work right now. Coming, but on Microsoft timeline, who knows, in 3 months, a year, I don't know. All right, while we're waiting, how many of you guys use Excel every day in your work? Okay, fair number. That's good. How many of you guys use Python in your work every day? Okay. Wasn't sure at a PyData conference how many people are trying to learn Python. No Python and are then intrigued by Excel. Even though this says like advanced Excel analytics, we'll get deep in the woods, but I will cover the very basics of Python and Excel. So no experience is necessary. We'll cover it all. Yeah. If you come over and type equals py, will it work? Probably not, yeah. This is Windows. What channel are you on? There's different channels. There's on the main channel, or it's called current channel. Python Excel should be there. Some employers are on a slower release cycle, but yeah, sorry. Okay, I guess we'll get started.
Yeah. Good afternoon, everyone. Welcome to the session on advanced Excel analytics. We have Jim here, along with Timothy. Hello. From team from Anaconda, and they're going to take over the session on applications of Python and Excel. So, without wasting much of time, I'll hand it over to Jim.
Okay, thank you very much. Yeah, I'm Jim Kitchen, Timothy. We work at Anaconda. We work on Python and Excel integration. So we're working, obviously, Python and Excel developed by Microsoft, but we support them on the Anaconda side. And so we want to show you some of the tools and some things that are, first just how to use it, but also we'll cover some things that are not well documented right at the boundary of Python and Excel, getting things written out. If you have questions or run into issues, I'll probably have Timothy come take a look. I'll just try to focus on the slides. We got a lot to cover. If you have questions, though, feel free to raise your hand. We're not so time constrained that we can't talk about it. Just want to mention other people that helped with this. Owen Price is also at Anaconda. And then Chris Gross and Kayur Patel from Microsoft gave us some much needed information on these less well documented features. Just to sort of give you an overview. Again, I'll give a brief overview. We're actually going to take these two and swap them. I'll cover the conversion types. That's going the Excel function. I'll cover that. We'll do some custom reprs. That's getting data from Python back into Excel. And then we'll build an end-to-end workflow using NLTK. Okay, so I've already mentioned this. If anyone came in late, you need to have access to Python and Excel if you want to follow along. That means you need the Windows desktop version of Excel on the current chip. If you go in your grid like this and you type equals py and you hit tab and you get a nice oops. Basically it turns, come on thing. All right, try this again. Wow. Okay, you hit tab and it turns green, then you've got Python in Excel. If not, then you'll just have to watch. Okay. Second thing, we will be using the Anaconda Toolbox. For that, you need an Anaconda Cloud account. So if you go to just anaconda.cloud, you can create an account. That'll be needed for the toolbox. Or again, if you don't want to sign up now, like you could just watch it, follow along. And then that's only a small portion of it. And then lastly, the Anaconda Toolbox we'll be using, so within Excel, you come to the Home tab, click on Add-ins, and search for Anaconda, and you'll see the Anaconda Toolbox, and you could just install it like that. So that will add some extra buttons to your formula grid, and I'll, again, be showing off what that is. So first, some Python and Excel basics. All right, we're going to come and type equals py, and we'll just do something simple like 2 + 2. Important, you have to hit Control Enter. If you just hit Enter, it'll just make a new line, and it won't actually execute it. You always have to hit Control Enter. But now we get the number 4. You get this nice little bracket py. You can click on that, and it'll show you some information about this Python object. The Python string is just 4. It's an integer. Some nice things. If I change this instead and say ARR equals, let's just make an NumPy array, 0 to 50 by 2. Again, if I hit Enter, it makes a new line. You may want to expand your formula bar so you can see better. And now I can do like ARR plus 100. Okay, now Control Enter executes it. And now I've got a NumPy array coming here. And now this has a different kind of representation. Shows me, a view of that. If I actually want to see the result spilled all the way back, right next to the green py bar, there's this icon right here that says Python object. And you can change the output to an Excel value. If you change it to an Excel value, it'll spill that whole array down to the Excel. So you can toggle back and forth. You can keep things either as sort of like the Python object, or say I want it to fully come back to Excel. Okay, in here I define the ARR variable. So now if I make a new Python and Excel cell, I can just say ARR.sum, run that, and it'll give me the result. So it knows what ARR is. This, you could think of these as basically, it's like you had a Jupyter notebook, and in one cell I defined ARR, in the next cell that variable is available. One thing Microsoft chose to run all these cells in row major order. So if I take this and move this cell up here, it's going to break. Because Excel is going to first try to run this cell, and then it'll run the cell where ARR is defined. It won't work. So you get this nice name error. If ever you get this Python error, you come over here and you just have to mouse over it, and you'll see the error right there. If you click on it, it's not helpful, but if you just mouse over it, it tells you that. So we will instead move it back to there, and then it works. Again, it can be below or to the right, but it has to be, row major. Okay, so we've got that covered. Let's talk about referring just to other things that are non-Python related. So if I just put a 5 here in cell F1, and I come and make a new Python cell, I can say Excel of F1, and then +1. All right? And now I get a 6. So this is how you refer to some other cell. I typed it out here, but if you wanted to, you can also just come and click that cell, and it'll fill in all the text for you. So anytime you want to refer to some other cell, that's the notation that'll come out. All right, yes.
Can I also say I'm in column F, so I want F1 and then I can drag and
Yes.
Python stuff.
Yeah, we're about to show that. Yeah, so let's, if you're following along, grab this chunk of text right here, and let's paste this in F10. This will give us a table of values. And now we're going to do exactly what you were saying. We're going to do equals py. And what I want to say is df equals, and I'm going to grab this whole thing. And now you see what it did. It went and grabbed the reference. This F10 pound sign, it is Excel notation for a spilled cell. So this spilled range, it detected that it has headers. And whenever you pick a range this way, Python and Excel will always convert it into a pandas data frame. So in this case, this is helpful. We like pandas data frames. Sometimes that's not helpful, and you wish it wasn't a pandas data frame, but for now it is. So I can, do something like df.describe. And now I get the nice data frame with description of it like that. We can do all the pandas things we want, so let's go ahead and make a plot. Swap that out. And now I get this image that is much nicer if I put it as an Excel value. And this may surprise you that you can actually fit an entire image inside a single Excel cell. But luckily, they gave you this little helper here that says create reference. You click on that, and now you've got basically a linked reference. So you can move wherever you want, and it's always pointing back to I10. So when you're doing Python images, this is like the recommended way. Drop it into a cell, but instead of having to expand that cell, just make a reference, and then you can move it wherever you want. Okay, so that's the basics. I want to show off the toolbox real fast. So if you come to the formula bar and you've installed the Anaconda Toolbox, you'll come in. I'm already logged in. This is where you sign in with your Anaconda Cloud account. But there's a build visualization here, and we're going to make a little bar chart. And we'll choose the same data range that we picked before. And I could pick student. We'll plot that against the score. And I will pick the output cell. Put it, I don't know, just drop it right there. And I click create. And it went ahead and wrote Python code for me. So the toolbox doesn't actually do the work. It just writes the Python code for you. That before we were using the built-in pandas plot method, this is now using Seaborn, but we get a similar chart that, again, you can spit out. So we'll cover more about the toolbox in a bit, but that is the basics. Are there any questions on basic functionality of Python and Excel? Yes?
One quick thing, just, it's on a cell-by-cell basis. If you do equal pi tab,
Yes.
You can't say I'm turning it on.
Correct, it's cell-by-cell basis, yeah. The result can spill, as we saw here, but yeah, it's basically, instead of writing the formula somewhere else, like in VBA or something, each cell, think of each cell in Excel as if it were a cell in a Jupyter notebook. And then the mental model sort of clicks. All right, let us just go ahead and get rid of sheet 1. I'm going to delete that because we were just playing around, and instead we're going to make a new sheet. And let's call it data conversions. All right, so now we should have 2 tabs, reviews and data conversions. And let's talk about this Excel function. So I'm going to paste some data into cell B5. I will do it in a way that makes it so it looks prettier. All right, so we've got these different things. These are sort of the basic Excel types. You've got basically a Boolean, a string, some numbers. Excel doesn't actually support dates, but it stores as a number, and then you can format it as a date. But let's see how Python and Excel handles each of these. So let's equals py, and we're going to say val equals, just click true, and then we'll do type of val. type of val, dot under name. And it says, hey, it interpreted that as a Boolean. So if I drag the formula down, I could see it says, all right, it knows that it converted that to a Boolean, it knows a string, it saw that that was an int, that this is a float. It actually detected that these were date times, and it saw that this was a time. So Python and Excel does a good job. If you're just grabbing a single cell, it'll do a really good job converting that to the appropriate Python type. Just a note, dragging Python Excel formulas, dangerous. Like, I know that's like your Excel brain immediately wants to type the formula once and drag it. Each of these cells, the code is going off to Azure to run and come back. So you get this round trip latency. So in most cases, if you're going to deal with a range, you want to treat the whole range as a single table, do your Python computation, and spill the results in one thing. That's usually best practices. So I'm doing this pedagogically just to show you what it does, but don't try this at all. Be careful with dragging Python formulas unless that's really what you intended. All right, we showed this off before, but let's do the same thing. We've got some cell data pasted in F5. All right, and then in I5, we will make a cell, and we're just going to drag this. And again, you see that it makes the headers for us. That's nice. If I do the same thing, but this time I don't include the headers. So I'm just dragging this. Notice it didn't say headers equals true. So it was smart enough to look at what range I was selecting, look at the top row, see if it looks different than the other rows, and realize this wasn't, it doesn't have headers. However, it still makes a data frame. So in this case, it made a data frame whose column headers are just 0, 1, 2, 3. Like that's. So let's say we want to change this. We say, I don't always want it to come as a data frame. I want that Excel method to bring it in as a NumPy array. So let's go do that. Normally, okay, something else I should have shown. In the formulas tab, there's this little Python section that you can insert Python. If you don't want to type equals py, you can click this button. But there's also this initialization panel. If you bring it up, these are like the default imports that exist in Python and Excel. So as you're using Python and Excel, you don't have to import NumPy as NP. NP is just available because basically every cell already has all these available. And as well, at the bottom, you see it says set default conversions for the Excel function. So let's look at this. There's this Excel library that Microsoft put in here. And there's a set Excel scalar conversion, and they're passing something, and a set Excel array conversion. So basically, when you're using the Excel function, if you click a single cell, it's going to use the scalar conversion. If you drag an array, it's going to use the array conversion. So this right now is read-only. We can't touch it. But in the future, this will become read-only, and we should be putting things there. But for now, we can't. So instead, we're just going to put it in cell A1. We want to do something that affects all the rest of the Python cells, so we have to put it in like top left corner so that row major order works. All right, so let's make a cell in A1. And let's go ahead and just, so we don't make any typing errors, we'll copy, paste this up in. Now let's talk about this. All right, so I'm making a function called our custom conversion. It takes an object, it's got a headers equals false, and some keyword arguments. All right, so this is the default signature for the Excel function. And so what we're going to do, this object thing comes in. For the array, it's going to come in as just a list of lists of objects. And so we could take this and just pass that directly into np.array. Then we call excel.setExcelArray conversion. We saw that in the initialization code. And now we're going to pass in our function to say, whenever you try to convert an array, use this instead of the default. And then I'm just writing a string. This is sort of a best practice. Without this, you get like a none because this setting the array returns none. And so by putting a string, it just sort of helps. It's almost like writing a comment inside of Excel that you're like, whoa, what does this Python cell do? You're like, I'm just doing some stuff, like doing the conversion function. All right. So now that I executed this, immediately you should see these guys used to say data frame. They now are ND arrays. So anytime you change a Python cell, all the Python cells get updated. They're always live. You don't have to run all cells. So now we have nice NumPy arrays. That's great. Okay, let's make this a little more flexible. We don't necessarily want everything to be a NumPy array. So let us instead paste this, and then I'll explain what changed. Okay, same signature, but instead I added a new type equals data frame. So I pulled that out of keyword arguments. And now I'm going to ask if the type that you passed in is, ND array, like something like this. I'm going to check to say that you didn't pass headers in, and then I'll make a NumPy array. If the type is data frame or none or something else, then I'll just use the default like pandas. There's the Excel convert to data frame method. I'll just pass that on. Okay, so now I run that, and now we can see that these switch back to data frame because the default is stat. But I can now come in here and say, if I want this, I could change this to type equals array. And now I get a NumPy array. So I sort of like preserved the base functionality, but added an extra keyword argument that you can now overload. Okay, let's add a few more. Let's keep going with this because I want this to be flexible. So let's grab this and see if we can make some simple dictionaries. All right, so now I say, if the type you passed in is either the dictionary object or the string dict, then I'm going to assume that it's a 2-column dictionary where the first item is the key and the next is the value. So we execute that. And now I can come and say equals py. Let's just drag these. And I want this to be a dictionary where Alice has a value of 97 or 94 and so on. So I come in here, add a type equals dict. And now I've got a Python dictionary. The representation is a little weird, but it is a Python dictionary. With other, if this was, I gave this a name of D, I could just come in here and say D bracket dot, and I'll get the value of 88. Right. So it's a normal dictionary. So trying to extract a dictionary out of a pandas data frame, annoying. By just updating our conversion function makes it a lot nicer. And all right, here's one more just to round it out. We'll make it so you can grab lists out of things. So if you ask for a list, I'll check to see, basically is it a 1D list or a 2D list? Because remember, object is always a 2-dimensional list of lists. And so if the length is 1, I'm assuming it's vertical, and we'll pull it out. And so now we can extract out just a list of items. And say I want it as a list. And now I've got a nice Python list. Okay, so discussion, like why would you create custom Excel loaders? You could just get your pandas data frame and call dot values and sort of pick the piece out. That works, that's fine. But I find there's a lot of times that going through that extra step, one, it just adds extra compute, and two, it makes your code busier and harder to read, right? I just want to write a cell where I'm showing that I'm going to aggregate things or do something, and having the Excel dot values, dot drop NA, or like, it just clutters things up. So separating out your conversion function, if you're going to be using that a lot in your spreadsheet, you're building out a big spreadsheet and you want to always use NumPy arrays or you want dictionaries, really streamlines things a lot. Okay, any questions about how this works? Okay. Something to talk about that is not obvious at first. The Excel function is actually a macro. It is not a true function. So there's some magic that's going on behind the scenes where Excel is actually doing some pre-processing before it sends your code off to Azure. Because once it's on Azure, it can't like tunnel back to your spreadsheet and just grab the data in cell V1. Instead, Excel has to like pass that along as extra arguments. So, if I come in here and make a Python Excel and I say like, my address is whatever, we'll just say V5, right? And then I want to say Excel of adder. Excel's going to complain and say, that doesn't work. Like it's just going to give you a key error because this Excel is not a true function. Instead, the pre-processing broke. Similarly, if we want to try to do an F string, like so, just copy it. This should work, right? Like inside of an F string, this should evaluate, but when you run it, it'll give you an error again. Like I don't know what A1 is. Similarly, if you try to do like a partial function, where I want to query this and say, I'll make a new function called Excel headers where the headers are always true, and then I'll just call it on a range. It's going to fail and say, sorry, key error. So just, yes.
So I'm sorry, this is going back to Azure, it's packaging up and go back to Azure. So if I'm on an airplane and I have Python and Anaconda installed on my laptop, I can't do this.
Python and Excel, no. Oh, well, I mean, if you're paying for the on-airplane Wi-Fi, I guess.
Yeah.
But yes, no, yeah, you have to be connected. This is, that was the other way this tutorial was going to fall down, is if the Wi-Fi couldn't handle all of us like making calls up to Azure. But we're using small data sets.
But Virtual Basic didn't need to do that, right? Virtual Basic ran on.
Virtual Basic ran locally, yes. Yes, here.
Why
So, why?
You want me to cover that?
Sure, yeah.
All right. I'm gonna come up front so I can have a chance of microphone picking me up.
It's a valid question. This is one of the most asked questions about Python and Excel. So, yeah.
All right. So Microsoft and Excel specifically has a few contracts with its users that it needs to adhere to. One, the stuff that you produce today has to work 30 years from now. So with Python, you run into that problem instantly because you have a big problem of environments and versions and everything else. Second is the spreadsheet has to be the same whether I look at it or whether I email it to my boss. So there's another problem where you're running into versioning and environment problems. And the third thing is you have to be able to collaborate over it at the same time in the same way. So again, if you're not running on the same thing at the same time with the other person, you're back in that same world. So that's why they used Azure as the solution on this. It keeps it secure via the Azure interchange format. Azure can't see the data unless you've told it to see the data. And Azure can't see, and nobody else can get into that container where you're running. So that's why it's running on Azure. It solves a lot of environment problems. It solves a lot of security problems. It solves a lot of.
And all that makes total sense. So my follow-up is I work for an insurance company. I'm always very concerned about the compliance. And of course, a lot of our data is going to be PII. That may be a way, Microsoft's not going to sign a business associate agreement to protect my HIPAA data. So maybe this is a non-starter for my company.
Microsoft, I don't want to speak for them. I believe last time I talked to them, they're HIPAA certified, but you'd want to check with them to make sure that's.
Yeah, you have to talk with them, but there's some mechanism of running Azure Secure or something, so it might work, but it's a valid concern, because yeah, the data is running on the cloud. It's not running locally.
Thank you.
Correct me if I'm wrong here. I was researching Anaconda Toolbox and Python and Excel a little bit before coming here. Isn't Anaconda Toolbox the tool that you would use to run Python and Excel locally on local environments, or am I wrong?
That is Anaconda code. Yes.
That's Anaconda code. Yes.
So in the Anaconda Toolbox, there's bundled Anaconda code. I'll show it right here. There's Anaconda code here, and this could solve your problems. This is Anaconda inside of the add-in. We've basically re-implemented the same functionality as Python and Excel, but it runs locally in WebAssembly. So these Excel add-ins are just a web page, and because PyData exists, and it runs a lot of the PyData stack in WebAssembly, we can load the environment here. So yeah, pause everybody, we'll show you Anaconda code, and then we'll jump back to Python and Excel. But yeah, this is the other solution, and one of the reasons that Anaconda built it is for this very reason, that you want it to run locally. This takes some time. It's downloading, all the PyData files. Once that's done, you can make a new cell, and I can run. And this, it's got the same spill things, but if you look at the formula bar, it's just a custom function that we've done. But yeah, it's running locally and has different challenges. It can't run all the Python packages because if going run packages are compiled for WebAssembly, which is not all of them. Like you're probably not going to run TensorFlow. But it runs locally. Yeah, I mean, some people may want to do machine learning. Why not?
So
Anyways.
Just a follow up on that.
Yeah.
So I think this is very useful, but can I run a separate IDE with that interpreter, but in the kind of code?
Not yet. Something we could look at.
Because it's easy to develop tools in IDE.
Yeah. Honestly, one of the challenges is you're writing Python code, and we have to then convert it into kind of a weird format up here in your grid. So having the tight integration is helpful. But yeah, this is something we're going to keep developing in Anaconda because we think it's useful, and there's, anyway, so anyone who can't use Python in Excel for whatever reason, whether it's you got a Mac or compliance reasons you're worried about, like Anaconda code might solve your needs, and I would love for that. I can't go into detail about it during this talk. We don't have time. I got to cover other stuff. But Timothy and I are here the rest of the conference. Find us, and we would love to give you a demo and show you stuff. So, sound good? Was there another question? Okay. All right. That was, so the Excel function is getting data from the Excel grid into Python. We're now going to go the reverse. So now you've done your Python compute, and you want to get it back into Excel. So, all right. We're going to now jump. I made a new tab called Custom Reprs just to get a fresh, clean start. All right. So D4, I'm just going to make a new Python and Excel cell, and we're going to type just 50, right? As vanilla as you can get. We get this nice card view. If I click it, I showed this before. It's Python string and the type. Next, you may have noticed there's this little plus button. You can actually, these are called fields in Excel, and you can extract this. If I click this, it'll move it out to a 50. There's also another way from here to see it. I can get the type. I can get the type name. It just sort of like finds the next available cell, and it'll spill these things out. If you look at it, it's like this is d4 dot Python type name. So Python has built Excel has built these, not quite a class, but kind of, where you've got like attributes hanging off of them. And so now if I change this to list of range 50, these are dynamic, it updates, and now I've got Python string and these things. So even though this view shows it like this, these extra fields are still available. In fact, there's a new one, array preview, which is exactly what I was viewing in the card here with the dot, dot, dot. Like, it's just another piece, it's just a piece of metadata on there, okay? So this is sort of the default thing that when a Python object comes back and you leave it as a Python object, it's this, object that has metadata hanging on it. And so we can change those. But first, before we change it, let's look at the built-in reprs. So you've already seen that a list looks like this. It just shows you the thing. If I change this to a tuple, then it's got the same view, right? They just changed the word to tuple. A NumPy array, as long as it's a one-dimensional, is going to be the same. Basically, if they can figure out how to do a list view, this is sort of their standard representation. All right, let's go to D6 and we'll make a new one. So actually, back up. On the reviews tab, I've already got a table here of data that we're going to look at. This is a bunch of iPhone reviews on Amazon that I pulled off and put into a table. So, all right, I'll just copy it to make sure I get it. You can refer to tables just by their name. If I were to go click and drag, you would see it would automatically fill that in. So this is a view of that table now turned into a data frame. So this is the standard data frame view. It'll tell me how many rows and columns. It's got a nice scroll bar, and just like pandas, it sort of puts the ellipses to make it so you're not overwhelmed by the data. But it's still got the same, array preview, Python string, like it's got all those same things that you can see. One thing to note about this is that it shows the row index. However, let me get rid of this. If I switch this and spill it to the grid, the row index is gone. So Microsoft made the choice that if it's a standard pandas row index that just goes from 0 to n, they're like, that's not helpful, they'll just drop it. But in the Python object view, you always see it. Like you'll always see what that is. If we come up and change this to, let's grab the ratings score, so just a single column. Now we'll have a panda series. It says it's a series, but it still uses the same view, and as far as they're concerned, it's just a one-column data frame that shows it. And just to show off again, if I spill this, it just is a single column because the row index is simple. If instead I made it a non-simple index, so let's do some filtering on the pandas data. This first. All right, so if I filtered it just for the country Mexico, now suddenly I've got the row index that shows up because it's not simple 0 through n. Anything that's not 0 to n, it's going to display. So if you don't like that, and you want to get rid of it, then you're going to have to write your own code to say dot, all right, what is it, reset index, drop equals true or something. Like, so you'll have to do that if you want to get rid of it. Just heads up of choices that Microsoft made that make sense, but you got to be aware of them. All right, we looked at switch this back. All right, let's look at images. We saw this before, but now I make an image. Here there is a view that this also is a dot field object, so I can click that and actually pop the image out while keeping this as a Python object. That's allowed. From here, you can also get the reference that I was showing before. If you right-click and go to Picture and Cell, then you can create a reference off of that. So this image technically is just another field, but the other way is to turn it into Excel value and then create the reference there. So these are the standard built-in, like the list view, the data frame view, and the image. All right, but let's create our own repr. So sometimes there's not a built-in view. How many of you guys ever use complex numbers in Python? It's not very common, but it's a built-in thing. If you didn't know, here's your. All right, so you could just type 25 plus 42j. And this is now a Python complex number. You could, who knew, right? Guido likes complex numbers. So, so we know it's a complex number. You can see the type and everything. But if I take this and try to turn it into an Excel value, the fine folks at Microsoft never built something to handle this. They just give you an NA and they're like, yeah, we don't know how to do it. Like, just they throw up their hands and they're like, sorry, you got it. So what are your options if you really want to spill it? You could manually come and say, like, c.real, c.match, and you could, like, spill it out yourself, right? So you could do that. If I want to go horizontal, you're like, yeah, you have all the flexibility. Just make it a two-dimensional list. It's wide now. You can spill it that way. So, like, you're in control, but if you're doing a bunch of stuff with complex numbers and every time you wanted to spill it, you had to, like, do this at the end of, like, it would just complicate your stuff. So instead, we're going to associate an Excel value. All right, so we're back in cell A1. Again, this normally should go in the initialization. This would be the right place to put it, but for now it's read-only. So we'll just have to stick this in cell A1. All right, so let's grab this code. All right, so I made a function, complex value repr, takes a complex number, and we're going to spill it so it spills out wide. And now there's excel.repr.register repr Excel value function. You pass it the Python object type and the function associated with it. Once you do that, now we can come back and get rid of this and just have it as the normal complex object, and it'll do the thing. It now knows what to do with complex numbers. Okay? So that's one way. If you have an object that you want to build a repr, again, this is only needed if you want to spill it to the grid. If you're keeping it as a Python object, like the default will always just be some kind of standard ugly view. Foreshadowing, we're going to make this prettier in the future, but for now, we're just taking it. This is only when you're spilling it to the grid. All right, let's make our own point class. Let's try this. So go to cell B1, and I'm going to make a point class. And because I own the class, there's a fun dunder repr method. So just single underscore repr Excel value single underscore. If this method exists, Excel is smart enough to say, okay, it's an object, I don't know what to do, but if it has this special method, I'll use it. So you don't even have to like register it. Just the fact that it exists on your object. We can now come and make a point class. So let's say b equals point, 3, 4. And again, it's a point object. Cool, but if we try to turn it into Excel value, then we get this nice, x is 3, y is 4, because that's what we said it should be. So if any of you are open source library maintainers or something, and you have your own classes that you work with, you can get your library ready for Python and Excel by adding that method, and then in the future, it'll know how to represent itself. So nice that that is there. Okay, any questions so far? Okay, we're now gonna, instead of, this is nice and all, but we're gonna switch this back to these Python objects and figure out how to can I control what this looks like? And the answer is yes. So, all right, I left a link in here. There is a big article that shows you how to do this in JavaScript. And you can do fancy things like this. You can put images, you can, Microsoft has done a lot with this. But it's super complex, and I'm not covering it all today. So if you want all the nitty-gritty details, it's out there. It's called a card with entity value. Today, we're going to just keep it simple as I can. But let's jump in. I'm going to go over to cell A1 here. We'll paste this in, and let's talk about this, because there's a lot going on here. Okay, so, oops. Get rid of that. Okay, so at the top, this was registering the repr Excel value. This method, we're going to do register repr Excel preview. So Python and Excel differentiates the value is when you spill it, the preview is that card view. So we're going to, again, for the complex, we're registering this function here. And the key is we're just returning a dictionary. It just happens to be a very special dictionary with a very special schema. And if that value comes, Excel knows how to render it. That's all. So this is the same dictionary that JavaScript was talking about. So it has to have a type called entity. That's fixed. The text, you can put whatever you want here. So we're going to use an F string and write something. And then you specify some properties you want. Here we're going to pull out the real and imaginary property. We run this, and now all of a sudden this complex, you see it says complex with 2542. That's this text right here. This F string right there is what gets displayed there. And now if I click on this and look, it's got imaginary and real there. Instead of the Python underscore type string, it's displayed there.
We have a question over here.
Oh, okay.
I saw hands.
Okay, so these now are available as the fields. So back up. So as I click on this, I can extract those out and actually, basically I've still got the same Python type string name, but these two fields are added now, the real and imaginary. I can pull those out. And now it's just d10.real. So essentially I can return an object that has all these attributes that people can then refer to. And in fact, they can refer to it wherever they want. I can still say d10.image. I can put it over here. At that point, it's just attributes on an Excel object. You may have noticed that the properties I listed as real and imaginary, but when it comes, they showed up as imaginary then real. That's because properties just are sorted alphabetically. Same with the fields, they're just sorted alphabetically here. If we want to change that, we can. Things get complicated, but that's what we're going to do. So let's go update our point class here. And all right, I will paste this in and then we'll talk, because this is a lot. And again, I don't expect anyone to be able to type this by hand. This is a little bit of trial and error. But now we've got this repr Excel preview. So there's a repr Excel value and repr Excel preview, Thunder methods. We're still returning the same thing that has the type entity, the text, and the properties. But now there's this extra layout section. So first of all, for our point, I decided to grab a couple extra things. I'm bringing out self.x and y. I can make a distance property that you call a function. My point class, I've got this distance method. I can do an array where I'm returning a tuple. And because it's a tuple, Excel knows how to deal with it. I can return a list of lists. Excel knows how to deal with that. So you can actually put some pretty complicated things. And as long as Excel knows how to deal with them, you can build up this sort of nested object. The layout, again, I'm not going to cover why it's like this, but layouts, you have to have the word card, different sections, and in here it has to say layout list, and then you can list the properties in whatever order you want. So we're going to have one section where we list x, y, and distance, and another section where we list the array and table. And again, these are all the names of the properties I defined just above. Okay, let's run that. And now when I look at my point class, here again I see the 3, 4. That was the field name. And now I've got two sections with a little horizontal divider. It's got my x, y, and distance, the array and the labels. And you'll notice that these actually have a new icon. I can click that and actually have sort of a drill down view. If it's two-dimensional, you'll see it like this. If it's one-dimensional, it'll look like this. And these all spill. So if there are fields, if I click this, suddenly I've got, this is d12.labels. And again, I could move it wherever I want and see that. I can do d12.array, and they look like that. So this is actually nice. I can make a pretty complex thing that when it returns, all of a sudden people can pick out different pieces that they want and sort of manipulate it differently. And the really cool thing is that these, this call right here, d12.array, is just an Excel function. So I can actually mix it with other Excel functions. So if I didn't want it to be vertical, I can go ahead and add transpose around it. And that will work. It'll transpose that result. Normally in Python, you can't just transpose this. Right? If I tried to come up here and say equals transpose, it's not going to work. Once it's in this Python mode, it can only be Python code. You can't mix Python and Excel formulas together. They don't work. But once you've exposed these different attributes on it, now you can work with the attributes in regular Excel formula space. And these work like normal, so I can do sum of d12.array. That works. As far as Excel knows, it's just two items like that. So this can be really powerful usage where you want to take your Python and then you want your Excel users to be able to tweak with it, add those different attributes, build a custom repr, and then they have that power. Okay. Questions? This is heavy. This is deep stuff. Like, we're right at the boundary. This is not documented. If someone wants to go like look for this, you won't find it there. So you guys are now the wizards in the world with this blessed knowledge. Hopefully the documentation will be better. But for now, like, this is, I think, pretty cool stuff. But anyway, so again, to recap of these custom reprs, you can use this Excel repr register repr Excel preview with a type and function. Or if you're in control of the class, you can just make a custom Dunder method, the repr Excel preview. So we showed that with complex numbers where you're obviously not in control of that, and the point class where you are in control of that. We good? Do we need like a break? Stand up and stretch before? Okay. We good, Timothy? All right. He's reading the room for me. All right. Next, we're going to do some NLTK analysis. Actually, try to use some of this and try to see what we can do. Disclaimer: I'm not an NLTK expert. I'm not even an NLTK intermediate. If you have questions about NLTK, you got to use and talk to Timothy. I'm using it just because it's a bit real world, and I thought that would be fun, more fun than just like the foobar table or something. But in here, NLTK natural language toolkit. So we're going to be doing some sentiment analysis with a thing called Vader, and I think it's pretty cool. You take sentences and it gives you a sentiment score. So these are sentences. Vader is smart, handsome, and funny. It looks and says what percentage of that is negative, neutral, or positive. So these three will add up to 1. And then it gives a compound score from -1 to 1 of like, what did that mean? Is it +1 that's really positive, or -1 is actually negative? It knows things about like exclamation marks, that makes it a little bit more positive. Adding the word very, it's like, oh, that makes it more positive. You get something where you're like a bunch of bold, uppercase and exclamations. It's like, yes, that is a very, very positive review. Whereas if you say the book was good, they're like, I mean, it was okay, but it's not a 0.96, it's a 0.44. And then if you say like kind of good, and finally you're like, the plot was good, but such and such. And they're like, yeah, that was actually a negative review. So I don't know how this works, but it seems to work reasonably well. So we're going to take that. We're then going to mix it with some iPhone reviews on Amazon, where the data set has different countries, the date it was recorded, whether it was a verified purchase or whatever, and then they give a rating score, 1 to 5 stars, and then they write a title and just free-form text. So we can do a sentiment analysis on this free-form text and look at how that compares to what star they give it, right? And we can, we're going to explore and see what we can do. All done in Excel. Okay, so as I mentioned, I've already pulled the data on the reviews tab. So this is all here, it's already a table. That's great. Let's make a new tab here and call it NLTK analysis. All right, so we'll go to cell D1, Y, and we'll just take this, call it the DF reviews. Whoops, no, I'm jumping too fast. I got to get all my imports first, because these are not built in. So cell A1. Let's get our base imports. Okay, so I'm going to import the sentiment analysis analyzer. I'll make an instance of that object, and then I'll make the DF reviews data frame. Okay. I've got the data frame. That took a little longer because the data set's a little bigger. It's going up to Azure, remember. Okay, now I can go to cell D1. I will say, Microsoft has done a good job on the latency. It's usually quite good. So as long as you have a reasonable internet connection, like it's not, you don't notice it unless you get really, really big data. But, okay, so we've pulled out the review description. I've got Panda series. I can look and see some of that. And now let's just talk about what this looks like in Excel. So, all right, I'm going to next say I want to build some scores. I'll just edit this. And I'm just going to take my reviews here, this Panda series. I'll apply the polarity score to each one. And I get some nasty Python error that none type object has no attribute in code. Is there anyone right away that knows the problem? I didn't either. I was like, what's going on? So, this is probably similar to what we do in a notebook. So I'll comment out scores. Let me just pick out one review and try to get the polarity score of that. Can I get 1? And the answer is, yeah, that worked fine. I got the compound, I got the negative positive. Okay, so it works. But trying to apply it to everything, it was breaking. If you do a Google search for this, it actually gives you a good thing and says you might have some none values in that string column, or the column you thought was a string column. Which makes sense. Okay, if it's a none object and I'm trying to apply encoding on it, it breaks. So we can look and say, all right, let me test that hypothesis, and look and say, give me the reviews where the reviews dot is in A. Find all those for me. And sure enough, there's a bunch. Okay, somebody gave it a star, didn't fill in the reviews. You would have thought the data set would give you an empty string. It didn't. Somehow the CSV came in as a none type. So, all right. Question is, should we remove those rows or should we just set them to empty string? Anyone have thoughts on that?
The second one.
The second one, all right, I agree with you. But there's no right answer. They're both correct. We're going to find it's easier just to turn them as empty strings. However, there's a result, there's a cost. It means that someone gave a 5-star review, and it'll now show up as a perfectly neutral sentiment score. An empty string is going to have, if they don't know what the sentiment is, they give it a perfect 0 of neither positive nor negative. So that could affect our analysis. It's up to us. Okay, so let's take this and we will, where it's NA, we're going to set the values to empty strings. Then we get our score. Hey, and now it actually worked. Now we've got these. However, now we've got dictionary stuck inside of Panda series, which is not what we want. Luckily, I happen to know that there's a fancy JSON normalize method for pandas that will do exactly that. Take a dictionary and spill it out as columns. We could have done a Google search for dictionaries to columns or whatever, but all right, now we finally got this. I can actually expand that. Looks nice. We've got a sentiment score for each of those. So now we can combine them all back together. And combine it with axis as 1. And finally, we're looking good. We finally got our combined data frame with each row having the sentiment score and everything's good. So the question is, are we done? And this is Professor Kitchen here. I'm not actually a professor, but no, we're not. This, no one wants to see this. That is just dense pandas code. And especially sticking it inside of an Excel cell, so it's a bit hidden. Let's go and, who here has ever written an Excel formula that was more than 5 lines wrapped? I have, where it's a VLOOKUP of this dereference. It's the worst, and you can't do anything about it. White space is not a thing in Excel, but with Python readability counts, right? We've got, look at this. Microsoft even gave us color-coded syntax highlighting. Let's use it. Let's use white space. Let's use comments. This is way nicer to see what it's doing. People can come back. I'm hoping that Excel jockeys coming to Python, they're I don't know if I can learn this. They'll look at this and be wow, that looks really nice. That seems very approachable. So if you're going to write code for other people, you use the benefits of Python. That's good code right there. Okay. How are we doing for time?
That's a joke because I gave Jim Kitchen that code with no comments at all.
No one's judging here. No one's judging here.
We're at 410. Yeah.
We're at 410. Okay. Oh, perfect. We got lots of time. Okay. Okay. So I've got the data frame, but again, it's stuck here. One nice thing is we can spill this to the grid, and now hey, we've got the full table. I can do all the nice things. This is the reason why we use Excel. if this were dumped out in a Pandas, or sorry, in a Jupyter notebook, this would be in the output cell. It'd be tough to read, but like if Excel does one thing right, it's looking at big tables of data. Like you can expand things, you can do all the stuff you want, right? It's great. So let's use it. Like this is fantastic. However, one thing we can't do, this has me bummed, is we can't just turn the spilled value into a table. It doesn't work. So, but we at least have the table we can look at. And again, this is all just in one code cell. So let's jump over to, let's start visualizing the result. All right, so we're going to come to cell R1. Make a new Python cell. And, oh, sorry. This is where we jump into Anaconda Toolbox, because I want to use it. So one of the reasons we built this is so that you can build complex charts that Python does really well without having to know all the Python behind it. So we're going to come and we're going to make a box plot. The data range, we will go and choose a range. And we'll come over to D1. We can just pick that because it's spilled. It knows about the whole table. And we want to do the rating score by the compound. That's like our overall score. And then I want to output it to R1. We'll create that. And click it, and we have to make a reference. And now we've got a nice box plot that shows the rating score versus the compound. So this, let's look at this for a second. This is interesting. We've got 1 through 5 stars, basically. Actually, we can change this so it says the word stars. And we'll call this sentiment. That's nicer. Give it a second to recalculate. That's much nicer. Okay, so 1 through 5 stars in the sentiment. What's interesting is that for every star, like people, even if they gave 5 stars, some people still wrote very negative reviews. Similarly, some people gave 1 star and actually wrote a pretty positive review. I don't know, people on Amazon. But there's definitely a trend. Like on average, most people, if they're giving a 1 star, tend to be a little negative, and the averages are directionally correct, which I guess makes sense. No one, these are probably real reviews. No one's trolling, trying to like be fancy. It is interesting though, just how apparently people who give 3 stars like tend to trend positive. They don't go negative, whereas 2 stars, there's a lot of variability. Anyways, we could poke at this more, but this is at least something you could show your boss, right? You could talk out in a meeting and say, I did my analysis. And more importantly, you could email this spreadsheet to your boss, and they can open it, right? This isn't a Jupyter notebook. They open it, they see it, and can play with it. So that's nice. All right. Next, let's do word cloud. Because the reality is, as cool as this is, Excel has, it's got box and whiskers. Like Excel does do charts too. So let's find something that Excel definitely cannot do, which is word cloud. So we are going to use another feature of the toolbox, Anaconda Toolbox here. We're going to go back and we're going to do the AI assistant. So this is Anaconda's version of like Copilot or whatever. But we've got it integrated here so we can say, I want to aggregate or summarize a table. We'll choose the range, and again, pick this table, and say, yeah, let's do some summarizing or aggregation. And it looks at the table and gives some suggestions of things we could do. We're going to ignore it completely and say, AI, this is really what I want. I want to filter the table to only show rating 5, and then make a word cloud from the review description field. And it actually does a pretty good job. We look at it, it imports from word cloud, import word cloud. It's going to do a matplotlib plot. We get a filtered DF with the rating filtered to 5. And then it does its magic. So Now that we've got this here, we've got this little run coded sheet button. I can come and say, yeah, put it right there. And it'll just copy this over and let it run. Okay, and we've got a word cloud. Look at this thing. So pretty cool. And again, so Anaconda Toolbox didn't do the analysis, or it didn't build the word cloud for us. It's merely wrote the Python code that gets run in Python and Excel. But that's still very valuable for us. So, okay, we've got this word cloud thing, and we notice some of the words are not helpful. Like, I get that phone and iPhone are very common things. But in word clouds, there's a thing called stop words, which is a list of words like a and the, on, like words that are not like very common, but are not useful. And so word cloud has a built-in list of those stop words that says, are basically they're ignore words. But we can add our own. So let's, all right, actually, I was supposed to put this in, let me follow my notes here. This was supposed to go in T26. Move that. Okay, so let's go to R25. And we're going to paste these words in. Make sure the formatting is good. And we will go ahead and turn this into a table. And we'll name it, ignore words. Oops. This was actually wrong. I want it with headers. That's better. All right, so we now have an Excel table called ignore words. And now we're going to put a 5 there in T24. Okay. All right, I'm going to make some changes to this code. And just to make sure that nothing breaks, I'm going to paste it in and we'll talk about the changes. And you'll see why we're making these changes. So, okay. First of all, I put $signs on this reference. So when you can actually drag Python formulas, and the same logic that Excel formulas uses applies. So it'll take the references and try to do them. By putting $signs, it says, this table is fixed in place. Keep that frozen. I've imported stop words. And before we had the rating equal to 5, I've now said it's equal to T25, which is right there. So make it equal to a value that we control. I've now got the built-in list of stop words, and I'm adding to it. Right here, I'm taking the Excel with the ignore words table, and you see this from before. We had the type equals list. I'm going to do that. Actually, I need to rearrange these tabs. I'll do that in a second. And then we're going to pass those stop words in. So this is going to give me an error, or it just won't work properly. Yeah, because I made a data frame. That is because my data conversions were in cell A1 of a tab on the right. And row major order applies to the tabs as well, like the sheets. So it executes the leftmost sheet and the rightmost sheet. So if I drag the sheet over, then this is going to magically start working. Yes, okay. Because now this type equals list it knew up, we'd registered it at this point. So, okay, so we now have this. We're looking good. Let me expand that a little bit. Let's go ahead and say like all the other ratings, 4, 3, 2, 1. I can now take this and drag it, and it'll make, because the reference was to T25, now in this cell, the reference is to U25. Like all those work. So the normal things that are magic about Excel that you like, they work here. We're going to take these columns, and instead of making references, we'll just make it a little wider and make this bigger. And now we can sort of see the ratings, and we look at, say, all right, good camera, great, good camera, for the 1 rating, it's got like product and Amazon. I don't think that's helpful, so we can just go ahead and add something to our stop words. Because this is a table, it auto expands. Because we're referring to a table, we don't have to like go and edit our formulas to like make the selection big enough. A good reason to use tables. Use tables. And now that it regenerated and got rid of that, now we still have the word apple. So maybe we'll add apple and get rid of that. Here's, I don't know what this A word is. It's A with an accent. We'll paste that in there. Anyways, but this is just another thing. You can look and see that 3, 4, and 5 stars, apparently they liked it. They thought the iPhone has a good camera, maybe a decent battery. The 1 stars, most of them, you're looking and it's about like buy and bought, and you're like, this probably was issues with like the buying process. It didn't come in time. It got delayed in shipping. It was broken. You're like, okay, so that's probably not an actual 1 star on the phone, but more on the process of buying through Amazon. So, anyways, things that word clouds can tell us something. Whether this is the right way to analyze it, I don't know. This is just an example of things that, the power of an Excel spreadsheet. You could, again, show this to your boss. They would know how to do stuff. So, questions, thoughts on this? Yes?
This is really cool. I'm curious, can you programmatically affect Excel formatting through this?
You cannot. No. So again, the mental model is, think about when you open a Jupyter notebook, you type in all the code, and then you run it. Behind the scenes, there's a kernel that's running. All it knows is it got a string of text that said, run this, give me a result back. So Python and Excel is that kernel. It's running on Azure, but it doesn't know that it's not a Jupyter notebook talking to it. It has no concept that it's running inside of Excel. So yeah, it unfortunately cannot. I mean, honestly, the only formatting we could do was like with this custom reprs, is you can pass a dictionary back that Excel is like, oh, that looks like something, and it'll do it. But like Python, yeah, I wish we could. I wish you could come back and say like, make the cell red if it's this or green or not, but you can't right now. So, and unlikely to be able to. This is where people want like a VBA replacement. Like these are things you could do with VBA because like with Visual Basic, it's controlling the spreadsheet. In this case, Python and Excel controls Python fully. Python cannot control Excel at all. So yeah, it's an interesting mental model. Still very powerful, but yeah.
That was an intentional decision by Microsoft. I mean, you probably don't want malicious code shared with you to be infecting your spreadsheet and then probably your computer. Like having Excel control Python and not Python control Excel was a very, very intentional decision.
Yeah. They remember all the VBA macro virus spread issue, and they were like, Python is really powerful. They did not want Python running locally on your computer that like can do anything. So yeah, it's Sandwall. It's running on Azure, and that container, when you're done with it, gets trashed. So like, if I'm running Python and Excel and you're running Python and Excel, we have 2 different instances in Azure, so we can't. They want to make sure I can't like exfiltrate data or somehow read stuff. They're very security aware. Okay.
We should probably talk to that security because it does have a couple of limitations. I'm gonna come up and
Come talk to it, yeah. And I think what we got 20 more minutes?
All right, so security, kind of a big important thing, especially if you're the size of Microsoft, right? Security is a big liability at that point. So what Microsoft has done through Azure is they've created a steel box where nothing comes in, nothing comes out, unless it's coming explicitly from this spreadsheet to that specific box. All highly encrypted, highly encoded steel box. So what that means is there's no internet connection on that steel box. There's no network, not well, there's internet because it has talk, but there's no network connection. So that means that you won't have every package available to you through pip installs. There's cost to this. What you do have available to you is what's included in the Anaconda installer. So if you install Anaconda onto your computer, that's what you have in Excel. Some of those packages require internet access like NLTK requires internet access to download a lot of the corpora. So what Microsoft has had to do is they had to pre-install select most popular corpora for NLTK. So there's limitations to what it can do, and that's one of the big limitations. But it is based around security because you don't want your data getting out. So when Jim was talking about if you have a library that you want to prepare it for Python and Excel, that's why we can't just say, go put it in Python and Excel or get it ready now, because it has to go through the right process to get it there, and that's a process that's still very young, and we're still transparently figuring out a lot of between Anaconda and Microsoft.
Sounds good. Okay. Any general Python and Excel questions? Otherwise, I think we've got time. I'm going to show off Anaconda code. So
Do it.
time check
Sure,
for me.
good.
Okay. So again,
4:23.
4:23. Okay. What time do we end?
4:30? Or 40?
4:40. Okay. Excellent. All right. So Anaconda code. I mentioned this before. So we can make different design decisions, and we did. Not that one's better or not, they're just operating different spaces. So Anaconda code, again, the code is running locally, but because it's a web page, it has internet access. So we can show you the environment. Right here, we've got PyData 0.25.1 in the packages. You can install other packages. So if you want different things, as long as it's been compiled for PyData, we can install it. So you want Kiwi solvership, you can install that. Save changes, it'll actually download those packages from a CDN and run it. And this environment definition is saved with this workbook. So like, instead of just a generic environment that you're defining, it's tied to this workbook, so you can run against it, and then if you hand it off to someone, they have to install the same Anaconda Toolbox add-in, but then they can run Anaconda code with this environment. So the environment tied to the spreadsheet, we think makes a lot of sense. The initialization that's in Python and Excel that's read-only, we've got something similar. We call it imports and definitions, and of course you can edit it because we made that. What are other, the biggest change. So Python and Excel runs in row major order, and you have access to local variables. It's like the Jupyter Notebook model. We've got two different modes that you can run in. You can, you make something as if you run it in linked mode, then future cells will be able to access that variable. Like, so I can do AR plus 100 as long as they're linked cells. That'll work. However, most of the time you can run in unlinked mode, which what you would do here is we say I'm going to unlink it, and instead of using the variable name, you just it's similar to the Excel function. We call ours ref. Because remember how I said Excel is actually a macro, not a proper function. So we named ours ref to just highlight that it's different. It's a macro. So as a result, it always comes in as a 2D list of lists. But you can do the same compute. But now, because they're decoupled, I can take this and move it in. I can move it into non-row major order, and it works. So basically, instead of forcing you to put things in row major order, you can think like you normally do in Excel. Like I've got a value here, and I want to put something over here that refers to that. You can. You just make a new cell, and you just go ahead and grab a reference to it. You've got the reference to it, and now you can work with it. So that's like the biggest change. But otherwise, it should function very similar to Python and Excel. Let's see what we could do. We return. Link range, and go ahead and grab the reviews. grab that. I get a spill result here. All right, there's the table. If I want, I can leave it as a local Python object. It's got a different symbol here, but we've got similar views. And we're going to be improving this. But anyways, the point of this is if you want to use Python in Excel but can't for some reason, check out Anaconda code. There's some cool stuff coming that we'll be showing off in the future. So with that, I think.
Can I talk a little bit Anaconda code from a product point of view?
Please do.
Is that okay if I talk about it from the product? So at Anaconda, we're so excited about Python and Excel because it opens up the Python ecosystem to a whole nother user. That's really, really exciting to us. One thing that we're free to do at Anaconda that Microsoft isn't always able to do is move very quickly. Python and Excel was a long process getting it out the door. What we can do in support of that at Anaconda is play around, experiment, show these features ahead of time, and see if there are things that you want. So if there are things that you like about this, please let us know, because that's feedback that will make Python and Excel better. We are really, really excited about making sure that Python and Excel is the best that it can be. And so we're supporting Microsoft in that effort entirely. So we hope that you'll give us feedback on Anaconda code, things that you like, things that you don't like, things that you want to see, things that you would like us to play around with, because that's the space that we're in making this thing work. So that's why we did it. That's what we're hoping you'll get out of it, is sort of this early adopter playground. So yeah, there you go, the end.
All right. Show off UDFs.
Do you want to show off UDFs?
All right, we'll show off UDFs.
Go ahead.
All right, this is not released in production, but it will be in a few weeks. So user-defined functions, these are things you could do in VBA. So we can define a function here. And we'll just return, I don't know, x plus 20. All right? So I've got that. I define it over here in my imports and definitions. And I come into the Excel grid, and now I've got in the Anaconda namespace, I'm using a local runtime because again, we're not in production. Pointed at something, and now I've got everything running. So this, notice, as far as Excel is concerned, this is not a Python function. This is just a custom function that some add-in registered. And yet, when it gets called, it comes over, looks at our definition, runs it in PyData, and spills the result. So this is something we think is pretty cool. It has the same power, but instead of having to, execute the code, you can just define a bunch of user-defined functions for your Excel analysts. They put it here, and then they could just use it as if it were any other function. Right. So that's coming. And I think that's it. That's what we've got. So hope you guys are excited. We got deep in the weeds of Python and Excel. You now know everything I know about the interface between Python and Excel. And this is going to keep growing and evolving, but if you want to work in that space, I think it's going to be, it would be a good place to be like the expert at your company of Python and Excel as that grows, to be the person who knows and gets to build. Because I hope you guys all build together. This is something that is not just Anaconda or Microsoft, but again, as you saw, the reprs and other things, like we hope feedback will come and that this becomes a thing that, in the same way that Python has taken over machine learning and data science, we hope it is the next wave of Excel that people love and talk about and assume that if you use Excel, you must know Python. That would be a cool place to be. All right. Thank you.